Hey, all you cool cats and kittens. This is Mr. Dressel from Montview High School, here to help out with today's Do Now. Let's look at this first problem. It's asking us to factor a couple expressions. I'm looking at this first one, and what I'm immediately seeing is that this looks like it's in the form of one thing squared minus another thing squared, in this case x and 7. That happens to be a difference of squares, and that will factor into x plus 7 and x minus 7. Now, difference of squares always factors like this because you always distribute. If I was going to distribute this expression right here, I would get a positive x squared and a negative 49, and the other two terms, 7x and negative 7x, those two terms are going to cancel out. So, special case. Now, looking at this next one, I'm also seeing a special case. What I'm seeing is that if I took this middle term, negative 10, if I took that and divided it in 2 and squared that, call that b divided by 2 squared, that would give me this last term, the constant 25. That tells me that this is just going to become x plus or minus something squared. And this is, in this case, half of b, x minus 5 squared. All right, moving on. Based on the transformations, which equation best represents the quadratic? When it says based on the transformations, I'm reading that as transformations from the parent quadratic function, x squared. Now, opens downward, that tells me that it's concave down. When I see concave down, I think of a negative equation. So that tells me it's going to be A, B, or C. Shifted up 3, well, that's going to cross out B here. That's got to be A or C. And shifted 2 to the 2 right units. So I'm thinking of an expression that's going this way. When I'm going that way, I think of something that's happening later than normal, and that to me says that we are subtracting 2 from the input. Okay. For this one, looks like we're asked to find the trig ratios of this specific triangle. It helps that all 3 trig ratios are all the same angle x. Since that's the case, it might help me to just label this triangle. I'd call the opposite side here, that's the opposite. The side that's touching the angle x, but not the hypotenuse, that's the adjacent. And this last one, that's opposite the right, the 90-degree angle, that's the hypotenuse. So I remember the expression SOH TOA. That tells me that sine is equal to the opposite over the hypotenuse, which in this case would be 20 over 29. Cosine is adjacent over hypotenuse. That means I'm having 21 over 29. And tangent is equal to opposite over adjacent. That in this case is 20 over 21. And let's go to this last problem, which is equivalent to sine of 40 plus cosine of 50. Again, the thing that pops out as relevant to me here is that I recognize that 40 plus 50 equals 90. So this is one of those complementary angle kind of problems. What that tells me, since the angles add up to 90, that means sine of 40 is equal to cosine of 50. And since there's that equivalency, that means I can basically think about using substitution. I'm looking at all these problems and they all have sine in them. For all of these answer choices. Since that's the case, I could use substitution and replace this cosine of 50 with another sine of 40. Now, the way I can think about that, just like if I have x plus x equals 2x, if I have sine of 40 plus another sine of 40, that is equal to 2 sine 40.